Okay, first consider turning tool geometry. Since CNC machine tools have adequate rigidity as well as high spindle speeds, cemented carbide or ceramic tools are used. Okay, this is the general consideration. In case of CNC machines, so we prefer to use cemented carbide or ceramic tools. That means tool inserts are made up of cemented carbide or ceramic material. So here, whenever you are making a decision regarding which tool insert should be used, okay, for that you should consider tool geometry. Every company, okay, manufacturer of tool inserts will provide a catalog, and in the catalog there will be all guidance. Okay, you don't get confused. Everything will be made clear in the catalog. So just you should go through that. If you go through the catalog of tool inserts from any company, you will get an idea regarding which tool you should use. Okay. So for example, I have downloaded one catalog. Okay, so this is a catalog from one of the tool insert manufacturing company. Similarly, in online only you can download. In Google, if you search tool inserts catalog, okay, you can get catalog from different tool manufacturers. If you go through that, you will understand. Okay, so here again, depending on which machining operation we are performing, so we will have different tool inserts. Okay, here HSS drilling, then solid carbide drilling, indexable insert drilling, reaming, countersinking. For everything, so there are tool inserts. Okay, so almost every catalog will be like this only. In the initial pages, they will uh, give you description regarding how you can understand the coding of the two inserts and tool holders. And what do you mean by that? So here you can see symbol explanation. Okay, then so depending on the tool material. Okay, so if you consider a particular tool insert, whether that is suitable for a particular material, that also you can check in the catalog. Okay, and these are the tool holders. Okay, that means so before going for making a decision regarding which tool insert should be used, so you can go through the catalog from various companies. Then you will have an idea regarding the work part material. Okay, so which you need to machine. Okay, based on the properties of the material of the work part and the on the contour that you want to get. Okay, you can go for picking the tool inserts, and again operations that you need to perform, whether it is turning, okay, or in turning or in drilling, whether you are removing material internally or externally. Okay, so there are many considerations in drilling also, countersinking. So based on that, so you can choose the tool inserts. Okay, this is one example of such coding. So here ISO coding system for tungsten carbide inserts used in turning. So here on the tool insert, okay, you will get the coding as TNMG 220408. So again, every alphabet or number has its own meaning. Okay, in this particular coding, T means it will indicate the shape of the insert. Okay, insert may be triangle in shape, square, round, and diamond with different angles. Okay, here T means, so this insert shape is triangle shape insert. Next, n value is about insert clearance angle. So if it is n, clearance angle is 0 degree. Instead of n, if t is followed by p, that means clearance angle is 5 degree. Next, m is the tolerance limit. Okay, so here m means so the tolerance that you can get with this using this insert. Okay, so there will be dimensional error up to plus or minus 0.002. So again, if it is G, plus or minus 0.001 mm. So next, G is insert type. That means with hole, clamp, with chip breaker, hole and special features. So G means this particular tool insert in this insert type is clamp on with chip breaker. Next, so this number 22, it is the cutting edge length. Next, 04 number, it is the thickness of the insert. Next, last number 08, this is the nose radius. Like this for every tool insert. Okay, so there will be a code, and in the catalog itself they will specify how to understand that code, how to decode it. Okay, by following those instructions given in the catalog, easily you can decode it. Then, so before that you should have some idea. Okay, so you are looking for which type of tool insert made up of which material, whether it is made up of tungsten carbide, okay, or it is ceramics. Then what should be the nose radius? Okay, if you have specific requirement in the tool catalog, okay, you can search for your specifications. Okay, you can get some matches. Okay, so based on that you can make a decision. Even cutting conditions will be specified by the manufacturer of the tool insert. Okay, so they will specify the cutting conditions. So if you are operating the machine at a particular feed, okay, next, so you should choose this insert. So like that they will specify based on the cutting conditions also. So you need to pick a particular type of insert. So here, the single point cutting tool geometry you have studied in UG. Okay, so during in manufacturing science, you have studied geometry of single point cutting tool in detail. Okay, you know the meaning of cutting edges, rake angle, clearance angle, all these things. Okay, so in case of CNC, instead of having a single point cutting tool as a single component. So here it is an assembly. So where you will have a tool insert, then there will be a tool holder. Okay. What is the reason why inserts are used in CNC machines? Why we cannot go for having a cutting tool like in conventional machines? What is the reason? Or what is the advantage of using inserts, tool inserts?
Sir, because the smooth surfaces, it cannot handle or it cannot fix that toes very easily by using this inserts.
One thing is navigation, okay, reach.
Yes, sir.
Okay, next. So comparatively, so the cost of tool inserts, because so these are made up of, okay, so exorbitant materials. So if the size of the cutting tool is large, okay, obviously cost will be also very high. Okay, so inserts they are very smaller in size. Okay, and if there is wear, again you should replace. So if it is a single assembly, you should replace the entire component. Okay, whereas in case of here, so only if you replace the tool insert, that is sufficient, which is very smaller in size. Okay, that is another advantage. Okay, if there is tool wear, so you can replace the insert. Okay. So the inserts, they have different shapes, triangle, square. okay, or diamond shape. Okay, so depending on application, so we will choose these also, okay, depending on the requirements. Next, so as we seen here, so this is the tool insert and this is the tool holder. For choosing tool holder also there are considerations. This is the coding for turning tool holder. One example, this is the ISO coding system for tungsten carbide turning tool holders used in external turning. So here also P means clamping system. So top clamping, rigid clamping, top and hole clamping. So here P means, so here clamping system used is hole clamping. Next, C means insert shape. So here it is diamond shape with 80 degree. Next, L means holder style. Okay, so here the first letter represents clamping system. If it is P, hole clamping. If it is F, S, screw clamping. If it is M, top and hole clamping. Okay, if the second letter is C, second letter represents insert shape. If it is C, the shape of the insert is diamond. If it is R, the shape of the insert is round. Like that, the second letter will give information regarding shape of the insert. Next, third letter will give information regarding holder style. Straight shank with side cutting edge angle 0 degree. Okay, straight shank with 15 degree side cutting edge angle. So like that, the third letter will give you information regarding holder style. Next, fourth letter regarding insert clearance angle. Okay, N means clearance angle is 0 degree. Okay, B instead of N, if the fourth letter is a B, that means clearance angle is 5 degree with the particular tool holder. Next, R, whether it is right hand, left hand or neutral. This is also very important. Next, shank height and shank width. So that is given by the numbers. Next, so this letter, okay, letter second from right side. Okay, this will give you toe length. So H means, so it is 100. Okay, next cutting edge length is given by the last number. So like that. So in case of inserts or tool holders used in CNC machines, okay, so they are coded, and this is how we can read and we can understand the code. Okay, so depending on the requirements, the actual selection of the tools for a particular application has to carefully match the geometry. So here it is a geometry or contour. Okay, so what is the shape of the work part? Okay, so how you should remove material. So that also play an important role regarding its selection. So here typical contour capability of external turning tools. Okay, suppose, so if you want to get 93 degree, okay, if you want to remove material like this, okay, then you should use this. So this insert and tool holder is capable of getting a contour having 93 degree. Okay, so and approach angle is 25 degree. So like that, there are considerations, okay, regarding the selection of tool and tool holder and the contour, the features of the work part. This is another example, typical contour capability of internal turning tools. Okay, maximum you can get up to 93 degree using this. So here you can get up to 75 degree using this. Next, modular tooling systems for turning. So modular means, so they are flexible. They can accommodate a variety of tools. Okay, that is called as modular design. So if you don't follow this modular tooling system approach, the problem is you need to have, if there are 5 different tools, okay, and 5 different tool holders with different shank sizes, then for every time okay, so you should change the tool holder. Okay, so in order to avoid that, so you will have some common feature in the tooling system, so that so for variety of tools, okay, you can use the same holder. So that is the advantage of going for modular tooling. So the shape of the tool may be different, or the size of the tool may be different, but where so you are holding that tool, okay, so that will remain same. The tooling systems used in CNC turning centers make use of different shank sizes and shapes, which require different tool holders for clamping them securely in the tool turret. This makes the tool change function as well as the design of storage magazine a difficult one. Okay, so in CNC machine, in tool turret, you can hold 12, 16 tools at a time. Okay, that means you can call the tools one after other. Okay, you need not waste time regarding tool change like in conventional machines, since tool turret consists of so more than one tools. Okay, it can accommodate 12, 16 like that. Okay, that means you can perform operations continuously one after other by making use of 12 different tools. Okay, that is possible in case of CNC. That means so the time taken to change the tool, even that should be very minimum. Okay, so that you can perform the operations quickly. So and you can reduce non-machining time. This makes the tool change function as well as the design of storage magazine a difficult one. That means so if you don't follow modular approach, okay, suppose if you need tool holders, okay, for a particular tool. So if the holder is different, so then every time you need to change the tool holder also. Okay, so it will limit uh, the scope for okay, so accommodating more number of tools and the scope for reducing the time of tool changing. This difficulty can be eliminated by adopting a modular tooling system in which all the tools have the same type of holding method. So that means you can use the same holder for different tools. In these tool modules, the clamping end remains the same, whatever is the type of tool. Okay, here, so you can see, so these are the tools. Okay, but if you look at the end, okay, so this is the end. The diameter and length of this end is same. So though there are these three are different tools, okay, all the three tools can be held by this tool holder. Okay, so this can accommodate so three different tools because so modular tooling approach was used. Otherwise, suppose if you have different sizes, so instead of having same diameter and length, if the diameter of this part, the shank, okay, is different, so then in this system the tool change takes only a few seconds. The reason is so the system need not check for that particular tool holder, since any tool holder can accommodate these tools. Okay, after finishing a particular operation, immediately you can fix it to any tool holder. Otherwise, the system has to search for that particular tool holder which can accommodate that particular tool. Okay, so that can be avoided with the help of modular tooling approach. Next, milling tooling systems. So we discussed about turning. So next is milling. Okay, in case of milling, so it is a tool holder is an assembly. Okay, it consists of a number of parts like retention knob, adapter, collet. Okay, and there will be, in this case, in this illustration, they have represented the drill bits, slot drill. So instead of this, so you may have any other insert used for milling. Okay, milling tooling systems. A milling tool to be used in CNC machine tool is an assembly of number of parts besides the actual cutting tool. Okay, so this is the actual cutting tool. Okay, milling cutter or drill bit. So here, in order to hold this, so we are making use of a system, okay, which consists of retention knob, adapter, collet, and each having their own function. Okay, retention knob, as the name itself indicate. Okay, the function of retention knob is to retain or release the component, or retain or release the tool. Okay, if you want to eject the tool, so you can press this retention knob and it will be ejected. Adapter, the function is to suit the spindle taper. So the shape of this adapter will depend on the shape of the spindle. Okay, so depending on the hole in the spindle. Okay, so you will have the shape of the adapter. If we have tapered hole, then adapter also will be having the similar tapers, so that it will go inside that and it will get attached to the spindle. Next, collet, for holding the straight shank of the end mill. Okay, so this portion is called shank. So collet will hold the shank portion of the end mill. Retention knob, used for retaining or releasing the tool from the spindle. Okay, so this is the retention knob, and these are different designs of adapter. Okay, depending on the taper of the spindle hole, so you will have the shape of the, or you will have the same taper, same ratio. Next, tool presetting. Okay, in CNC machine, one of the important thing whenever if you want to operate the machine, okay, so tool presetting is very important. Okay, so usually operators will call that as taking offset. Okay, offset ತಗೊಳ್ಳೋದು ಅಂತ ಹೇಳಿ so ಹೇಳ್ತಿರ್ತಾರೆ. So that is very crucial. That means, so it is a process of taking the reference point from which, so you are going to consider incremental positions. In order to consider that reference point, okay, you need to make the system understand that this is the reference point. For that, there is a procedure. So that is called as taking offset. Okay, so this tool presetting is also related to taking this offset. The relationship of the tool with reference to the tool holding mechanism requires a special attention during CNC machining process. The actual point to be programmed in a CNC part program is the tip of the tool, where the axis will be moving with respect to a known point in the spindle. So that means you will give x plus 100, y plus 100, like that. You will specify the value. Okay, what is the starting point? What is the 0 point? Okay, so that is defined by this tool presetting. Okay, that taking that reference point. To know precisely the deviation of the tool tip from the gauge point on the spindle, tool setting equipment is used. So it consists of a C clamp and micrometer. Okay, micrometer is used in metrology lab. Okay, so here also micrometer will be used to know the exact position of the tool. Okay, or to get that reference point. So this arrangement is used. Okay, this is the micrometer, already you have used in metrology lab in UG. Okay, so here this is one setup. Okay, so for used for tool setting. So in the setup, so this is the base. The base is provided with the exact taper as used in the actual machine tool. Okay, so here you are fixing this assembly. Okay, so tool holder assembly, so tool assembly, so to the tool setting system. Okay, so here also in order to accommodate like how it is going to fix to spindle. Okay, in the similar manner, so you are going to hold this assembly here. Okay, so for that you are going to provide the taper. The base is provided with the exact taper as used in the actual machine tool. The assembled tool is therefore placed in the spindle taper. So this here there will be a hole, so tapered hole. So you are inserting this adapter to the tapered hole. Measurement is done with the help of a micrometer head. So this is the micrometer. So this is the micrometer, which is attached to a U clamp. So this is the U clamp. The U clamp can be moved manually on a post which has precise location slots that are separated by an exact distance. So in this case it is 25 mm. The length of the tool can therefore measured by the measurement of the micrometer plus the slots along the post. Okay, so here after placing the tool onto the tool holder assembly, that means that consists of adapter, collet, okay, and retention knob. So you are measuring the length. So if you have an idea regarding the length of the tool when it is kept in this tool holder assembly, so then you will get an idea regarding how to take that reference point. Okay, so you are measuring the length by keeping the tool inside the tool holder assembly. So for that we are using this presetting system. Some presetting systems are also provided with an optical projector so that the point of contact between the probe end and the tool can be more accurately identified. So this is such example of using optical projector. So here you are using dial gauge. Next,